Okay, so fun story. Ted and I have just been through the first part of our presentation already. I forgot to hit the go button, and we are nothing. It went to dead air. So let me go through this one more time. Tonight, welcome to Kansas City Java User Group. And tonight we have Ted M. Young, who's going to be talking to us about our primitives. All right. First, we want to thank our sponsors, Clinical Reference Laboratory, for sponsoring our meetup.com page, where we can get our meetup organized, and YRC Freight, who, even though we're not meeting in person, has long time been a supporter of our in-person meetups. So we want to give them a shout out, and we plan to continue meeting there after we begin meeting in person again. All right, Java news for the month, which covers December and January. Not a lot, but the JDK 18 feature set was frozen in December. Some of the highlights of that is an inclusion of a simple web server, so you don't have to have a standalone web server to spin up your Java web applications anymore. Code snippets in JavaDoc, which may not sound cool, but as a documentation wonk, I love this one because it's going to allow your IDEs to give you things like code completion and syntax checking in code snippets in JavaDoc, as well as deprecation of object finalization. So that finalize method on the Java object is being deprecated with the intention of it being removed. There was also a big information dump for Project Valhalla, which, if you're not familiar, Project Valhalla seeks to kind of create some parity between Java objects and Java primitives to more efficiently use memory. For releases this month, I don't know if you guys heard, there was a couple of releases of Log4j2. There was a pretty big vulnerability that was found in the Log4j2 release. And it allows remote execution on the server. So the gist of this is get on the latest version. There was a release, and then that release had a vulnerability, which was released, and then that had a vulnerability. There ended up being like 3 or 4 different versions that were released before all the vulnerabilities actually got fixed on this one. In addition to that, check your other dependencies. Several things, especially frameworks, shade in Log4j2. So check all of your dependency release notes to see if there's anything that mentions Log4j2 or Log4Shell or Logjam, because there's a chance that this vulnerability was present in something that doesn't necessarily declare a dependency on Log4j2. All right, and other news, conferences coming up right now is the JChampions conference, which is virtual. You can go to jchampionsconf.com and check that out. DevNexus is also coming up in April. It's scheduled for the 12th through 14th in Atlanta. It will be in person, and you can find out information about that at devnexus.com. And I will share the slides after our presentation is over, so you don't have to worry about trying to remember these websites. Local meetups, we're going to have the Kansas City Jug next month, February 17th, which is third Thursday, our typical meetup date. We're continuing to be virtual. We'll be featuring Deshaun Carter, who's a Spring developer advocate. Our topic is not yet finalized, but once we get that finalized, we will send out messaging. If there's anything we missed, let us know, and we are happy to give it a plug. And last, get involved. This meetup is about our community. So if you can attend and tell your friends and grow our community, the meetup will only get better. You can like and subscribe to our YouTube channel. I mean, you're already there, you might as well. Suggest topics, speakers, and locations, and volunteer to speak. I think our paper call currently is out of order, but we can work on trying to get that set back up again. But you can always reach out to us on Twitter at KCJug, or reach out to us on Slack. You can find that link to our Slack channel on our website, and provide feedback. Again, I'll share this presentation with everybody, so you will have access to all of these URLs. All right. So without further ado, I'm going to bring Ted M. Young back on again. All right. Ted M. Young is a principal Java trainer and coding coach at Spiral Learning. His focus is Java, TDD, and Spring. And tonight he's going to be talking to us about primitives.
All right. Thanks for having me, folks. And just a little bit more about my Java experience, since that's what we're here about. I've been doing Java for pretty much as long as you've been doing Java outside of at least the time Sun. So what, 26 plus years. And what I'm here to help you with is stop obsessing about primitives. I am a coach, and so I look at a lot of code bases. I work with a lot of teams, and one of the things that I find is everywhere is people are using primitives. So in terms of questions, if you have them, throw them up there. I will answer them on the fly, or someone will bring them to my attention. But I want to start with a little story about the lowly username. So there's a project, and it was using a username that was a string. And so strings were being passed around everywhere. So, and that was fine. That worked. There's not a problem there. Then we're integrating with a system that had some limitations on the characters that could be used in that string. And so they said, all right, well, we'll add some validation here. Oh, we missed it over here. Oh, we still have some ones in the database that are wrong. So we'll go ahead and do some stuff over there. And then more and more got piled up in different validations. And as you can imagine, if you haven't already experienced something like this, you've got now strings all over the place that are being treated slightly differently. They're all usernames, but they're supposed to be treated the same and consistently. And in fact, so this caused some problems. And so this is the kind of thing that we sometimes just say, oh, that's just the way it is, and we'll deal with it. And so when we're talking about primitives, the question then is what are they, right? So we need to define our terms here. What do I mean by primitive? And so Valhalla was mentioned by Brandon in the opening. And so I'm looking forward to that, but it doesn't really solve this problem, although it actually makes it a lot better. So I am certainly looking forward to Valhalla and Loom, and then I'll be a happy camper. I don't know what else I would want. But when we're looking for primitives in terms of this, basically this code smell, where do we look for them? What are we looking for? So let's talk about first, what are primitives? Often when we think of primitives, we think of sort of the usual suspects, right? Those ints, longs, floats, chars, what Java explicitly calls primitives. And so these are the usual suspects, and I didn't have a comprehensive list here, right? You could say, hey, you forgot char, you forgot short, you forgot double. It's like, yes, all those are sort of the primitives, and we know that they have wrappers, but they're still basically primitives. The special case is Boolean, and in classes I teach, so some of this comes from a class, and Booleans always come up, and it's really fascinating. I every time I see a Boolean, I'm always suspect. It's like, are you sure that there's not some sort of hidden state machine here? So Booleans are really of their own class. Then we have the typical string. And like I started with the story of the username, we sometimes store information in there, and we have to do validation. Sometimes we actually store what really is type information and making decisions based on what's in that string. And this leads to what is I think is hilariously called stringly typed code. And I still come across this kind of code where you have an if statement, and it's comparing the contents of a string to say, is this an individual or is this an organization? And if it's one, I'll do something. If it's the other, I'll do something else. You might be cringing at that, but in reality, that happens a lot. And sometimes it's not so obvious. What we really want in our Java code is strongly typed code, right? Using our type system to tell us when things can go wrong at compile time. The other set of things that I'm going to treat as primitives, even though you might say, what are you talking about? List, map, set, those aren't primitives. Those are collection types or data structures. In my experience, they often are involved in rich behavior. And what I mean by that is often we're using things like maps to do translations or transformations, right? We look up something and then we pull out something else. Maybe it's another object of a type, maybe it's another string that we're translating to, or maybe it's a class that we instantiate using reflection, who knows? So there's a lot of that kind of thing. And other structures hold, it's not just a list of things that we just hold on to and then just print out somewhere, right? We often process them, summarize them, aggregate them in some way. And there's a lot of behavior around those structures. And so really what primitives are, and I'm going to call them unconstrained types. So they're types, but they have just whatever their built-in constraints are, completely unrelated to the work that you're doing. And so an example of that is Bint, right? It's got a reasonably large range to it, right? It can go from negative 2 billion to positive 2 billion something. I don't know about you, but I don't think I can think of a case where I use that entire range. Most of the time, I am concerned with using a portion of that range. So for example, one of the code bases I use in my classes is a blackjack game. And in that game, we basically want to support betting, right? So want to support a wager. And certainly we do not allow the full range of an int to be a wager. First of all, 0 may or may not make any sense, but certainly negative 2 billion makes no sense. And probably have some reasonable limit. And so what we want is we want to be thinking about what is the constraint type that's specific for our application, for our domain. So I'll be using this word domain a lot. And if you're not familiar with things like domain-driven design, domain is basically like, why are we building whatever we're building? What is its purpose, right? Is it a blackjack game? And so then the domain is cards, hands, dealer, whether you go bust or not, whether you get blackjack, whether you win and lose, what your bet was, and how much the payoff is. That's all part of the domain. And so I use the word domain instead of what I used to call business logic back in the olden days. But now we just call it domain. And that's the core part of our application. And so we want to be creating a rich domain language. And to do that, we need to stop obsessing about using primitives all over the place. So we've sort of seen, what we're talking about when we're talking about primitives. We're talking about these unconstrained types. Then we need to look at, okay, where do we find them? Clearly we can't get rid of all possible primitives because at some point we have to store things as primitives. So where we're looking is basically instance variables. So for example, we might have a private string username, method parameters. So we might have a method, a command method called change username to that takes a string for a username. And we might also look at return values. So we have a method that returns a string. And so these are all places where we might look for primitives. And then we have some further work to do to see how do we figure out, is this a problem or not? We don't look at local variables because if we define a variable inside of a method, its scope is to that method, and it sort of doesn't escape out of that. So we really don't pay attention to that. And honestly, I don't really define too many variables in locally, because if my method's that long where I'm going to have a bunch of them, I probably want to pull out and extract some methods. So this is sort of where we sort of look for them, and we know what they are, but sort of why are we looking at them? What's the problem? And so we got us hinted that with the username story. And so what's wrong is often we have mixed responsibilities and dispersed logic. So let me show you a code base that I'll be using in a bit. And yes, I know it's the light theme. Get your sunglasses ready for those of you who prefer dark theme. I am a light theme person. Don't shoot me. So here we've got a class. This is part of a tiny application that sort of simulates a coffee vending machine. And we can see here there's instance variables, but there's not a lot of sort of information. And one of the things that we find is partially because this has getters and setters, which I will talk a little bit about, there's logic around some of this information, right, around this stock thing. First of all, what the heck is stock? I'll talk about that. But we've got getters and setters, and so that means there's logic that's elsewhere in the system that's doing work. So all the way over here in some other class, we've got something that is dealing with this variable. So the logic around this thing, which is really keeping track of the inventory of the items, it's all over the place. So part of it is because we have a getter and setter, but part of it is also because we have this primitive, and it gets mixed up with other things. And so as we saw, it's generally these primitives are not self-documenting. Right. So again, here, if we look at ingredient, we see stock. What the heck is that? Who knows? This int here, this doesn't tell us very much. It doesn't tell us, well, what's the range? What's the minimum value? What's the maximum value? Can I increment it? Does it change? By how much? Or what units are these? Right. So this, one of the most important things that we find missing is basically units and range. The last thing is, and this is particularly close to my heart, is testing. So I am a big TDDer. I'm big on testing and testability. And to me, one of the primary things that drive almost everything I do is, how do I test this? How easy is it for me to test this? And so when we have classes that have lots of primitives, and they have, each primitive has its own set of methods that's doing logic, then we have a class that's too big, and it's too hard to find things, and it's definitely too hard to test. So I basically created some rules around primitive obsession about how do we know when we found it, right? So we know where to look. We know what we're looking for. The question is that it? Are all primitives, if they're instance variables, suffering from primitive obsession? The answer is no. There's actually one more thing that we need to consider. So is it an unconstrained type, right? So is it a Boolean? Is it a true Java primitive? Is it an unconstrained collection? If so, okay, then we need to now look at, is it used as part of behavior, right? If it's just used for something that ends up getting displayed on some screen somewhere, then there's no logic associated with it, so it probably isn't a problem. Although that kind of information is actually more rare than you think. So if it's used in and involved in behavior, right? Decisions are being made. It's in an if statement, right? It's in a Boolean expression as part of an if or a switch or something like that, or you're looping through it, then it's starting to become a good candidate for primitive obsession. Now, this last rule is a bit of an awkward phrasing, but it's basically saying, have you already created and solved the primitive obsession, or is it a problem? So is this class doing other things? Is this class involved in logic around a bunch of different primitives? So if we go back here to this code, there's a bit of logic, and it's spread around the system around this variable. In addition, there's also logic around cost that's spread around the system. And so this thing is involved in managing all the logic around that. And we'll see another example in this main class are things like this drink list and this ingredient list. So we see these lists, and it's like, okay, well, they're slightly typed, right? They're generified, but they're still lists, which means they can be arbitrarily added to and removed from and scanned over and things like that. And so we have no information about what is this thing used for. So this idea of primitive obsession is almost a bit of anti-object oriented, right? I mean, to me, it's like, we're using Java. It's an object-oriented language. So let's like buy into that. Let's let's go full speed ahead on being object oriented. And when I see things like this, and then another list that holds other things, and I have no idea what is going on with these, who's using them, how are they using them, what are they for? And then we see a bunch of code that uses those lists. It means we've put too much in this class. Now, some people use the single responsibility principle to say, how do you know when like a method is too big or a class is too big? Well, when it's no longer has a single responsibility. I don't know about you, but that's never helped me. It's like, it just doesn't help me. It doesn't guide me on, okay, great, it's too big. What do I do? So one of the things I like about primitive obsession, finding it and then solving it, is it tells me what to do. So what do? We found something, we've found a primitive, right? An unconstrained type that's used in behavior, logic, or looping. And the class is not concerned just with that particular instance variable or primitive, but is also involved with a bunch of others. So the solution to fixing primitive obsession, to, as they say, deodorizing this code smell, is you create new types. Create new types, lots of new types. One of the things that I see in a lot of code bases, mine included, is not enough types, not enough rich types that tell you information about the thing that you're trying to work with. It's not just an int, but it's actually an inventory level that is empty when it's 0 and is full when it's 10. And you know that because there's a type called inventory level. And I'm not talking about creating 1 or 2 more types. I'm talking about often creating a dozen or more types, obviously, depending on the size of your application. And so one reaction I often get to this is, well, isn't that going to hurt performance? Right? You're telling me I need to create probably 5 times as many classes as I currently have, maybe even 10 times, who knows? In my experience, most Java applications suffer from far too few classes than too many. Not that there aren't ones that have too many, but usually it's too few. And so my mantra is that readability outweighs performance. We often overemphasize performance. Every single class I teach, every single team I coach, this idea of what I think of as sort of micro level concern about performance or premature concern about performance. Like, but wait, if we do that, isn't that going to hurt performance? If we extract all these methods into tiny little methods, isn't that going to hurt performance? If we create all these types, these new classes or records, which you can now do, isn't that going to hurt performance? And you know what? Most of the time, no. But if it does, it'll probably be easier to fix. If you prefer another meme for this, then here you go. So if anybody mentions performance, I'm just going to say, don't make me tap the sign. So readability is more important than performance. And it's not that performance isn't important. It's just that most of the time when we worry about performance, we're worrying about it too early. When we finally get a system up and running or get a part of a system and it's slow, then we can measure it and see what's actually causing the problem. So when I say create lots of classes and types, what am I talking about? All of these should be types in your system. A deposit amount, not just an amount, not just money, but a deposit amount, right? I'm sure you don't, if you're working, so I have a little piece of software called Kid Money Manager to help me manage how much money my son has because he doesn't have his own bank account. So deposit amount, there's a lower limit. I'm not going to deposit 0. There's an upper limit. Probably not going to deposit more than, let's say, $200 at once. If I do, probably something is wrong. It should have been 20. And so deposit amount has different constraints, different validation, but also it's not interchangeable with something like account balance. These are not fungible types, right? If you're just passing around money, right, money objects, or God forbid doubles, please don't use doubles for money. then how do you tell the difference between one and the other? One's an account balance, the other one's a deposit amount. If nothing else, if you give them types, then the compiler can tell you if you're using them in the right place. Then there are classes like %. You might think, well, %, that's just a number. Well, is it? It's actually a fraction sometimes. Right, so I was working on, with one of my coaching clients, writing a little quiz software and trying to give a final grade, which is a %. And that's actually a fraction. So is it 33? Is it 33 and a third %? What is it? But these kinds of things that should be encapsulated inside that type, and how you might build that % might be different. So the code to build a % is, am I building it from a fraction? So they got 1 out of 4 right. And then I don't have to worry about calculating that. That's the job of %. So it's not just that we add on semantic information, the type, and that the compiler helps us, but the code to deal with building the thing is inside of that class. So % would make sure it's correct. If I try to create a % that's the fraction of 5/0, we know that's not right. And so it can protect us against that. And we don't have to check that everywhere. And once we build these types, once we instantiate these objects, we know that they're correct. And so there's a saying that I've adopted, which is parse, don't validate. So when you get numbers and text from the outside world, right? So I always think of a system as being outside, where it's all just strings and numbers if you're lucky. And then inside, deep inside of our system, is this rich domain types. And when you go from the outside to the inside, you want to make sure that you've interpreted things correctly, and that those values and numbers and things become these rich things. But I don't want to do that all the time. I want to parse it once into a %, into a weight that has a number and a unit. Is it pounds or kilograms? Because those are different. And so we want to parse it once. Now it's an object. We never have to validate it again. So we've parsed that number, right? 22 with a space and then the letters kg for kilograms. We've parsed that string into a weight that now is something we can pass around and use. Other things like temperature, right? They have units. Without units, right, is 30 degrees. To me, that's cold, because I'm an American, and that's cold. To pretty much everybody else in the world, it's kind of warm, right? So these things are important. So we know what kind of types. So the question then is, well, which types do we use? Right? We don't always create classes. We may create class-like things. So Java supports and has syntactic sugar for things like enums. So if we have a limited number of options that we know when we're coding it, then enum is a perfect fit. Sometimes even just 2 choices warrants an enum. So for my blackjack game example, with playing cards, suit and rank, those would be great enums, right? Hearts, clubs, diamonds, spades. Your rank, ace, 2, 3, etc. All those are known. Unless you're writing a system that allows people to make up new cards, these pretty much, once you compile it, they'll never change. So perfect for enums, right? Don't store suit as a string. Don't store rank as a string. Create enums for them. For example, the outcome of a game. It's not just some string value or God forbid, like just some number. It's actual representations of different kinds of outcome states. Even something like an option contract type. So this is an example from, because one of my side projects is working on option contract pricing things. And this isn't a Boolean. There's 2 choices, but it's not a true and false kind of thing. Right? I would not have a Boolean that says is put. Right? That would, I hope you don't have anything like that in your code base. But I've seen that kind of thing. And sometimes it's not that clear. Right? Sometimes it's like, oh, I'll use a Boolean here. That seems fine. So for example, again, from my blackjack game, we talk about, is the player done? Right? Have they finished their turn? Well, it seems like that's a Boolean, except you may want to also track, have they started yet? Now you've got 3 states, and boy, you wish you had an enum. And for coffee ingredient, that's something that you might want to have an enum as well, depending on the system. If it's fully programmable, then you probably wouldn't want an enum. But if it's a fixed thing that maybe is connected to hardware, then you might want to have an enum. So the Mohawk has said a comment about 4K classes and 40,000 classes. Yeah. So if you're at the point where you're generating that many classes, that is certainly an outlier, and absolutely fix that problem. Very rarely do I see the number of classes be a problem. Usually it's not enough. So one of the really interesting things that I found is when you take something that might have been stored previously as a string and you say, okay, great, this is clearly primitive obsession, right? Right here, these are both suffering from primitive obsession. Why am I storing these as strings? Well, because it's convenient, right? It's hard work creating a type. It's very hard work. It's lots of work, right? We have to grind those out and walk 10 miles before we can finally get a new type. But it's not as straightforward, right, as just saying string. So we want to convert these to enums. And what's interesting is that things that might have required us to write a method with a bunch of if-else statements like we have here, it turns out that, well, this is really constant information. Why are we sort of evaluating this every single time to see what the value is? If we convert it to an enum, not only do we get a nice type, which means we can't accidentally pass rank and suit when it expects suit and rank, but we also get to take that, use what used to be logic and turn it into a constant. And so, which makes sense. It's like it's the value, the fact that a queen is worth 10 in the game of blackjack, that's intrinsic to that thing. Why are we testing and basically executing branch instructions every single time? But enums aren't always a solution for everything. If you have many options, or sort of the universe of what you can stuff into it is large, or maybe you want to be able to quickly substitute things, then you might want to use a value object. And so the term value object has been around for a while, but domain-driven design really popularized it. So some examples of value object are the United States zip code. It's not a number. It looks like a number because it's all digits, but it's not a number. We don't do math on it. And leading zeros, for those of you in the Northeast, are significant, right? 02134, I know that zip code because I used to watch a show called Zoom on PBS when I was a kid. And so that leading zero is important. You drop it and you've got a wrong address. So it's not a number, but it does have a limited set of values that are correct. But not all 5-digit values are correct either, right? So it's not only not a number, but it's not even a range of numbers, right? There's lots of 5-digit numbers that are not valid zip codes. Money's another example. It's one of the typical examples because it's one of those, you require units with it. What currency is it? What's your how are you going to round it, right? So it's not just value. So one of the things that over the years of talking about and studying domain-driven design, these things called value objects, which are generally immutable. Once you create one, you just pass it around. You don't need to store it anywhere. Is that money will probably have some behavior along with it. How do I add money? How do I multiply money? And then how do I round it? Do I round up? Do I round down? Do I use banker's rounding, which is half up? Do I just forget about it because it's a currency where decimals don't matter, like yen? All sorts of different behavior that's involved there. And you want that inside of that money class. But even money is insufficient because it's just money. It still has a huge range. And so even it is a bit of an unconstrained type. So money by itself, probably not good enough. Wager, that's probably good enough because it's not just money and currency, it's also what the range is and what you can do with it, and how it might calculate payoffs. Birth date is another example. So date by itself, if you know anything about date, it is, especially, our good old current Java date time, right? Like local date, huge range, right? Multiple number of years that nobody ever, very few people care about using either end of that range. And so for birth date, we may want to do things like constrain, well, it shouldn't be older than this. Let's say we want to cap it at, we don't expect people using the system to be over 150 years old. But it also must be in the past, because you can't have a birth date that's in the future unless it's a planned birth date, which is a very different type, right? You might have, someone who's pregnant and they think this is when they're going to give birth. That's a different object. That's a different type. They have very different uses and they're not interchangeable. So they're different types and they should be defined as such. I always have to laugh at vehicle identification number because it's not a number. Depending on how you define number, because I got a lot of letters in it, but there's a lot of deep, useful information, like which factory was it in, what model is it, and so on. So it's not really a number. Certainly, you don't do math on it. So as Billy says, it's like if you don't do math on it, it's not a number. Even though it might look like a number, it's not a number. Now, here's one that is really interesting, and this comes, again, sort of from domain-driven design. I first learned about this in Vernon Vaughn's book, Implementing Domain-Driven Design, where he talked about using types for entity identifiers. Right? So one thing we know about entities, right, things that we usually think about when we're talking about orders and customers and users, is they all have identifiers. And lots of work goes into, well, what do we use for identifiers? Do we use a long? Do we use an int? Do we use a UUID? Do we use a variant of a UUID that's sorted, case sorted, all sorts of choices? I could probably give a whole presentation on that. But the fact is that it shouldn't matter. All we care about is that it's unique. But it doesn't have to be globally unique, right? I'm not going to mix up user ID and customer ID, although I might if they're both treated as longs. If we're passing longs around or ints, then it's certainly possible and easy to swap them and accidentally pass what is really a customer ID when an order ID is expected. And it's like, I can't find that. But when you type them, you can't mix them up. You can't pass in a customer ID type if it's expecting a user ID type. And you might think it's annoying to use types just basically as a lightweight wrapper around some identifier. It's not that difficult, and you get used to it, and you find, at least I've found, it actually becomes natural, and it makes the code so much more readable. So enums are one way to solve it. Value objects, these types of things are ways to solve it for a different class of identifiers and primitives that we might have stored as primitives. The last one is what I call stateful type. So probably something as part of an entity. So it holds mutable state. We want to actually modify it itself. Whereas value objects tend to be immutable. If we need a different one, we throw away the old one and create a new one. Right? So if somebody moved from 94404 to 94403, two zip codes near me, we don't add one or subtract one, right? Because remember, we don't do math on them. We basically just instantiate a new one and say, here's the zip code. Hey, I want a zip code of 94403. And then assign that to whatever variable we have. But sometimes we actually want something to hold state. and we want to do things like its inventory level. And so we'd like to be able to reduce it, increase it, restock it, things like that. A blackjack hand is going to hold cards, and we'd like to be able to add them, find information about it, like what's its current value, order quantity. There might be a range. We might not allow people to order more than a certain amount, but we still might want to allow users to change that amount. This one is a little iffy. I would stick with a value object for this, but it depends on what your needs are. A shipping container might be something where it's you're trying to maximize how much you can put into the shipping container. It has limits, and so you sort of just keep adding things to it until the shipping container says, nope, I'm full. But then you can ask it things like, how heavy are you? And other kinds of summarizing aggregation types of things. So those are kind of the three different classes of things that we can do to solve primitive obsession. So what I'm going to do is basically refactor, do a little bit of refactoring to introduce and fix some of this primitive obsession problems. So turns out there's actually a fairly mechanical process to fix primitive obsession. So step one is make sure all the code dealing with that variable, right? Because again, you're going to usually talking about instance variables. Make sure all the code dealing with that is in one place. And so this idea of gathering things together where there's code elsewhere that's doing work is actually another smell that's very closely related to primitive obsession called feature envy. So feature envy is where we have behavior that's implemented against data that's really owned, and the responsibility for that data is in another object. So here we have a place where inside this drink machine, it does reduce stock, but instead of just calling a method on ingredient, it basically says, hey, how much do you have? I'm going to do some math, and then I'm going to go ahead and set the value back. This is sort of the ultimate in violating good encapsulation, and basically is feature envy. This one is kind of the more egregious type. But even this one, that looks pretty innocuous. This key part here is we basically ask ingredient, hey, how much you got? How many items do you got? What's the, presumably quantity? What's the stock level? And then I'm going to compare it to something else and then do something based on that. But this drink machine class doesn't own this information. So this decision being made here is in the wrong place. You don't want to get information from a class and make your own decisions outside of it, if it's information that you could turn into a question against that class. Right? So don't pull this out. Just ask the ingredient, hey, do you have enough to make this thing? So we need to make sure that if there is any feature envy, we fix that first. And once we do that, and we've gathered everything together, our goal is to get rid of that getter and setter. So let's go ahead and do that. So I'm a big IntelliJ user. I've been using IntelliJ for, let's see, I think they just celebrated their 21st birthday. So that's about how long I've been using it. So I'm a big IntelliJ fan. And so I'm going to use several automated refactorings that IntelliJ gives us to do this. The first thing that we want to do, since our first goal is anybody who's using a getter and setter shouldn't be doing that. They should be using something else. So let's gather all the code together into this class. So, and the way we do that is we basically try and find where it's used. So we look for usages. So here, a decision is being made, right? So this is feature envy. And the way we solve this problem, this specific problem of feature envy and trying to gather things together, is we want to take this code and basically make it a method on the ingredient class. And so the way we do this is we extract a method. Now, one thing you have to be careful of when you're doing this is it looks like, oh, this is checking if it has enough inventory. It's actually asking, does there not enough inventory? Just because of the way this loop works. So we'll call it has not enough inventory for. And then once we have this as a method, we can use one of my favorite go-to automated refactorings, which is the infamous F6 key. And I say infamous because some people in my classes have been joking with me about F6 was the best thing I learned ever in this class. I'm like, what about all that other good stuff? So F6 allows us to move the method to really where it belongs. And where it belongs is in ingredient. So I'll go ahead and refactor that. And so I'm going to split the screen so we can sort of see where things go. So that method ended up here as a query method. So small little side trip around commands and queries. You should not have getters and setters in your core domain classes. You should have commands and queries. That's just good object-oriented fundamentals. You either want to ask your objects a question, like, hey, do you have enough inventory for this? Or you want to tell them to do things. Well, right now, there's not much telling going on. There's basically just barging in and saying, here's a value. So we'll fix that. So we've turned this method, we've extracted it, we've turned it into a method, and then made it a query method on ingredient. So we've fixed that feature envy. And again, this process of fixing this is mechanical. We basically just find all usages and move them. So we'll go ahead and continue to find usages of get stock. Come back to this one that deals with it as a string in a second. This one is that other sort of egregious violation of sort of who owns this information, who's responsible for it. So we're going to call this reduce inventory by. The idea of this is basically if we're making a drink is made up of ingredients. We've now used up this ingredient, so we should reduce the inventory that we're tracking. So we extracted it as a method, we've given it a good name, and now we can move it over to ingredient. And we know we're moving it to ingredient because ingredient is the class that really owns this information, so that's where it should go. So we sort of go back to here, look for usages. The last usages, and all we're looking for is usage outside of ingredient. And the last usage is this one, which is basically just for display purposes. So I'm going to basically say, okay, I'm going to create a method that's just for that, because you shouldn't be accessing this as a number. But you know what? We want to allow people to display it. That's fine. So we'll leave it as is, but I don't like getters, or at least methods that start with get. So I'm just going to say print stock level. Just a side note, there's a little bit of a problem with the language in this application. Sometimes it's called stock, sometimes it's called inventory. That would be something that we'd want to deal with and clean up, but we're going to move past that. So we've done that, and now what we can do is look at the set method. So where is set being called? So it's being called in a few places. One is in this place where it's restocking the ingredients. But it shouldn't do that. It should just be a command against the ingredient, say, hey, please restock to full. So let's create such a method. So now we can take this method and move it where it belongs. So far, we've created two query methods, questions that we can ask ingredient, and a command method to basically tell it to change its state to something that it knows how to do. So the information about where 10 comes from, that's really inherent to the ingredient class. All right, so we keep looking for set stock, and basically the only other places are in this are in these tests. So let's flip the tests over to here. This is just trying to set sort of the initial state of these things so that it can actually do some testing on whether update string state works, this other method. So really, this is all about setting the initial state. We don't need this. We can just pull this into the constructor. So let's go ahead and do that. I'm going to drive this through the test. Oops. Try that again. So I want to create a new constructor. This is going to be name. This is cost. And this is initial stock. So we'll pretty much do the same assignment here. And I'm not going to worry about tidying up my constructors. Do that. And we'll run the tests. And they all pass. That means this is equivalent. So I'll do the same thing here. I'll pass in 2, because really what this is doing is it's saying, hey, given a coffee that has only 1 left, given sugar that has only 2 left, and a recipe that takes 1 of each, can I still make the drink? Is there still enough? And so that's what this is doing. But only tests need this, so that's why I'm happy creating this constructor. So here we'll set this to 0. Here we'll set this to 2. Continue to work. We'll look for any remaining places where we've got set called, and that's it. So now set is not being used outside of the class. So the last step, at least for this part, oops, right, problems, is we can use inline method, because we don't need this method anymore. We don't want people to use it. It's useless, and we don't want it, so we'll get rid of it. So we'll inline and remove the method. So now all the previous places it was using the setter, that code is in this class that owns this information, so it directly accesses it. We want to do the same thing for current stock level. We want to leave it available here, but we don't need it inside the class. So we can go ahead and inline it here, but we'll keep the method. Oops. Inline this. And we'll inline this. So we've now fixed the feature envy, which was sort of the prerequisite. But in reality, what I often find is feature envy and primitive obsession are really 2 sides of the same coin. Feature envy says somebody else is making decisions based on information that I, Mr. Object, am responsible for. Hey, that's my responsibility to track stock. Why are you making decisions around it? Why are you directly modifying that information? You shouldn't be doing that. And so that's feature envy. So I'm gonna have that. But then there's all that code now that I have that I'm responsible for right here, mixed in with code that's responsible for other things like cost and for other things like the ingredient name. And so now we've got too much code in here. So we brought it all where it should be, but there's too much. And so now we want to take this and move it to another class. So by fixing feature envy, you often highlight primitive obsession. And often by fixing primitive obsession, you will highlight feature envy. So again, there are these 2 things. You sort of go back and forth until you finally get everything grouped into a new class. So let's go ahead and now create a new class with the same field. So now we're going to fix the primitive obsession. So we're going to use something called extract delegate to do this for us. But basically what it's going to do is it's going to create a new class that just holds that one piece of information, right? The thing that is suffering from primitive obsession. And we're basically going to have all of the code in the current class point to that new class. So we're going to refactor, use another fancy one called extract delegate. And what we're doing is we're extracting a new class, a new type, right? create new types. That's my mantra. Oops. We'll generate accessors for it. So what's happened now, I'll flip this over so we can see both. We've created a class that has one piece of information, stock, and ironically, getters and setters. Now, we just solved feature envy, right, to get to where we were. And then I created this class. In a sense, what I've done is I've recreated purposely feature envy. Now all of these getters and setters are actually feature envy. It's like saying, hey, what are you doing directly accessing my information? Let's get that over here where it belongs. And so by creating this situation where I've caused feature envy, I know how to solve it. I've done that before. How do I solve it? I find usages and move it over. And so that's why really primitive obsession and feature envy are so closely tied together, because you fix one, you cause the other, you try and cause one and you fix the other. And it's just this really fascinating relationship between the two. So we go through this same process, right? We basically just say, who's using get stock? Well, that's fine. He's using it here, for current stock level. So we'll leave that for now. Who else is using it? They're making a decision. But here we're crossing a line of, on the left side here, it knows about things like recipe. But on the right side here, it shouldn't actually know about recipe. That it doesn't need to. All it needs to deal with is numbers. So when we say here, has not enough inventory for, or even better, reduce inventory by, right? We just made this recipe, reduce it by how much the inventory, reduce it by how much the recipe requires. The concerns about recipe are here. The concerns about tracking that number and incrementing it and decrementing it are here. So what we do is when we refactor this, we split that up. We say, what we want to do is call a method on inventory level that says reduce, in this case says reduce the inventory by this much. Similarly here, we want to basically ask that question, do you have enough for this amount? So what we're going to do is we're going to sort of split this along those lines about the responsibilities and who has knowledge of recipe and who doesn't need it. And we'll extract this to a variable, and we're going to call this quantity needed. So now what we're left with is basically this decision, which is clearly something that is the responsibility of this new inventory level class. So we do the same thing we did before, which is extract method. And yes, this strange negated method name, we would fix that at some later point, I would hope. But for now, we'll just continue to use it. So has not enough inventory. Now we're dealing with an int for how much quantity is needed, because that's the units, and that's the value that inventory level works with. And now that we've done that, now we can do the same thing. Move our method over to inventory level. And now the question that the rest of the code asks ingredient, hey, do you have enough inventory for this ingredient to make this recipe? So it says, okay, well, how much do I need? This is how much I need. Hey, inventory level, do I have enough inventory for this amount? As an artifact of the refactoring, it passed in a reference to ingredient. We actually don't need that, so we can go ahead and delete that. So what we've done is ingredient now delegates the responsibility of keeping track of the quantity, right, the inventory level, while it still has some responsibility like translating domain concepts like recipe and figuring out what it needs to ask for in terms of a numeric amount. And so we do the same thing with, so we look for get stock. used here in this. So now this will solve the get stock and set stock problem again. But we have to pull this out because we don't want inventory level to have to deal with recipe. So we're going to pull this out into a variable. And again, we'll call it quantity needed. Now that we've done that, now we can extract this into a method, which is really the same thing, reduce inventory by. But now it's dealing with the quantity needed. Now, if you're already thinking, wait, is this int primitive obsession also? Then you get a gold star. For those who've been through my training classes or have otherwise been in various groups with me, they're already well trained to say, shouldn't that you just said quantity needed, shouldn't that be a quantity type? And yes, it should be, but you can only fix one thing at a time. So we'll go ahead and refactor that. IntelliJ is trying to be smart, but I don't need to be that smart. So we've extracted this method, which again belongs on inventory level. And we'll get rid of that unneeded variable. Again, mechanically, we just go back to set stock and get stock and see who's using them. Nobody else is using. Oh, wait, there's still a couple of places where it's initializing it. So let's go take a look at those. So we might want to say, well, isn't set stock 10 restock to full? Didn't we create something like that? And we did. So let's take this and move it over to inventory level. But that's bad because now we have created a situation that looks like this. And this is a violation, well, not only of encapsulation, but probably law of Demeter problem. So that's not quite what we wanted. Oops. So we still want, from the outsider's perspective of interacting with ingredient, we still want to ask the ingredient, please restock to full. But it's the set stock to 10 that we want to say, that's not an ingredient issue, that's an inventory issue. So let me drop the word this because that's annoying me. Let's extract this into a method, which is, we'll just call it restock. IntelliJ says, hey, you're doing the same thing over here. Would you like to replace it? Absolutely. Thank you very much, IntelliJ. And now this restock, that should be moved over to inventory level. And it doesn't actually need a parameter. So the knowledge, ownership of what does it mean to be full, right? What does it mean to be restocked? And now I'm actually going to say restock to full. I didn't want to do that where it was before because it would have conflicted with the existing method. But that's really what this is saying, is inventory level restock to full means set stock to 10. But that information is encapsulated with the thing that's responsible for it, which is inventory level. There's one other place where we have set stock, and that's basically initializing it. And so what we'll do here is, instead of saying set stock to initial stock, we'll actually basically convert that to a constructor. So Brandon asks about where the computation is, whether it's on ingredient or recipe. There are certainly other object-oriented encapsulation responsibility issues, and it's something we would want to explore further. But one of the things that I found is, by doing this kind of thing, finding the primitive obsession and fixing it, and the feature envy along the way, is things that were not obvious about responsibilities, because the responsibilities weren't quite in the right place. Once you start putting things in the right place and creating new types, it becomes much more clear that, hey, there's some weirdness about who's responsible for what. And then you can more easily address those. So, part of the problem is noticing things. And when you've got sort of code distributed around the application that's dealing with really a concept, a missing concept, then once you create that concept, it becomes like this gravity well that pulls all of the things that relate to it into one place. And then you can see, oh, wow, there's this thing here, and this other thing here doesn't make sense anymore. Maybe we need to reorganize that. So what we're going to do is we're going to take this, and instead of doing a set stock to initial stock, I'm going to basically do new inventory level and pass in inventory, initial stock. We'll go ahead and create that constructor. And for backwards compatibility, I'll create the no argument constructor. Oh, it already exists. Hiding. And generally, I'd want to make this final, but for now, you can't fix everything all at once. Trust me. You want to fix things incrementally, get things working, get things better than they were before. And one thing you'll notice, I've been not running my unit tests, which those of you who are TDDers or who know me are like astonished that I haven't been running my tests along the way. Generally, when I'm using a lot of automated refactorings like this, extract method, move method, extract method, move method, and then inline, I have a high trust level for those refactorings, and I generally don't run my tests very often. But we've been doing a bunch of refactorings, but all our tests continue to pass. Right, we've been doing this step-by-step, stepwise through getting to and splitting apart the code base a little bit more. And everything is still compiling and all our tests are passing, because this truly is refactoring. This is restructuring the code to make it easier to work with. So one of the nice things about this being a mechanical process is, now what was I doing again? Oh yeah, so create did that, change old scalar did that. Back to move feature envy methods. Oh yeah, so we basically are still looking for usages of the getter and setter. All right, so who's using set stock? Nobody. It's only being used internally. So we can go ahead and inline it and remove the method. In fact, sometimes what I'll do is as soon as I create these, I'll immediately mark them as deprecated to remind me that I don't want these sticking around. This is a temporary. Right? I don't want to have getters and setters. And then this reminds me that don't forget to remove these. This getter, so let's take a look at where it's used. So internally, we'll replace both of those with just access to the stock instance variable directly. Ingredient, well, actually, that's fine. So what we'll do is we'll just rename it to be an appropriate query method, which is current level. Here, we don't need to call that method. We'll just inline it. And same thing here, inline this. And now we're done. So this new inventory level class is now all the concerns, all of the, not that there was a lot, but all of the concerns around what this meant, how we interacted with that variable, are now encapsulated in these methods. We've created a new type that has query methods like, what's the current level, and do you have not enough to make this? Please reduce the inventory by this much, or please restock to full. Right? So we've got commands and queries. And the code relating to this is now been pulled out and separated. So the code that's left behind is easier to work with, because this is now more abstract than directly accessing that. And one of the things that I really focus on in my code base is readability. And not just, that something's easier to read, but it's also quick to read at a glance. So understandable at a glance. And by creating this new type, we've created a little abstraction. Right? Every method we create is an abstraction. Every class and type we create is an abstraction. And when I refactor and pull out and create abstractions from existing code, it's much more likely that they're good. I'm not saying I think this is what the abstraction is going to be, right? This, do a lot of design up front. It's not that I don't do design up front, but I let the code guide me on how to create new types and refactor to pull responsibility together. One of the things this highlights is like, are we allowed to reduce inventory lower than the current level? Then basically go negative is really the question. Are we allowed to let inventory go negative? We say restock to full. Are we allowed to add stuff back? There's actually no way to do that. So even though there's clearly some missing constraints, there are some built-in constraints, because the only way to interact with this variable from the outside world is basically through these two methods. Either we restock to full or we reduce inventory. There's no way to increase inventory. That's not needed by the code base. And that's a constraint. When it was in here as just an int, we could have done that. Whether that was right or not is dependent on what was needed. But now it's clear by looking at this class, we know much more about what was that value? What was this variable trying to do? What does it mean? So now we can look at this and say, well, wait, now you got an in stock. Isn't that suffering from primitive obsession? In this case, no, right? Because this class inventory level is not concerned with managing any other information other than this variable. So when we ask that last question of is it the sole concern of the class? This variable is the sole concern of this class. This class is dedicated to managing this information. Now, as I mentioned at the beginning, I'm all about testing and testability. Well, heck, this makes all the code here trivial to test. If I want to test to make sure my inventory level code is working, this is easy to test. Right? If I want to test, any of these things, I can directly instantiate this class, reduce inventory, and see, does this query work? Trivial. When it was embedded inside of this class here, testable. But if we look at the test that we're using it, not as easy to use. Right? A lot more setup was involved, when really what this is testing is some of the stuff having to do with ingredient. So it's great that, it's more readable and understandable. But again, my primary concern is how much more testable is this? So we may have had tests against, this class, but what happens is when you pull code out like this and create a new class. And so that's one of the things that I love about primitive obsession, finding it, is that it tells me what to fix, it tells me what class to create. So remember before I mentioned, I don't like the single responsibility principle. Not that I don't think it's a good principle, it just doesn't guide me. It doesn't say, here's what you do next. But the primitive obsession, once you found it, what you do next is you pull out a new type. And that slowly solves the problem. If you got a class that has lots of things, like I might pull out this, maybe. I'd have to see if it's worth it. When you pull these things out, the thing you've pulled out, the new type you've created, is now eminently more testable. And that's, for me, a huge win. So single responsibility tells me it's doing too much. Great. But primitive obsession says, and to fix that, create a type called inventory level. You've not only reduced the amount of code in here, you've given this meaningful names, and you've pulled out code that's now trivial to test. And so a question that comes up often for me as a technical coach is, hey, we've got these private methods that we're having trouble testing. Should we test private methods? And if you know me, the answer is no. Do not test private methods. The answer is there's probably a class, a new type that can be pulled out where what used to be private code in a private method, right? This used to be in a private method, is now completely visible to the outside world because it's on a new type whose job it is to manage that work. And so we get a bunch of benefits. We get inventory level, which gives us a meaningful name. And now if we want to say, hey, what does it do? What does it deal with? We can look inside of it and we may notice there's some constraints missing. Should we be able to reduce inventory if we don't have enough? So it actually forces us to notice some of those things. And then we could write it and we could write tests and test drive those constraints. Then we have to do is look at this class and say, what is this tracking? So Justin asks a question about how do you save these kinds of objects in the database? They're just objects. How do we save any object in a database? Objects have references to other objects, and so we need to save them and restore them. If you're using an ORM, then you just got to figure out how to map them. Sometimes they'll be embedded, right? So it'd be in the same table as the parent, and sometimes they'll be mapped with collection type mapping or join type mapping or one-to-many mapping, or in this case, it's probably just be embedded. When I'm thinking about my core domain, right, ingredient, inventory level, things that are dealing with what is this application supposed to do, I don't really think about persistence. So funny enough, I just finished teaching a class on hexagonal architecture, where today we basically discuss persistence. And for me, I'm very much a huge fan of hexagonal architecture. And to me, persistence needs to be kept at a distance from your core domain objects. You need both, but to me, domain objects and domain content and good OO domain objects drive everything. It's not that persistence isn't necessary or not important. For the kinds of applications I deal with, the domain is the primary thing that I need to worry about. And then I'll figure out how to store those and retrieve them from a database. So this is finding and solving primitive obsession for a scalar value, right? An int, a long, a string, those kinds of things. But sometimes you'll find primitive obsession, since I explicitly called it out. Thank you, PowerPoint. You can fix collection primitive obsession, and the process is almost exactly the same. It's a little bit different, but the idea is the same, right? You create a new class with a getter for the collection, and this getter is basically immediately deprecated because you want to get rid of it. But the idea is you want to pull out just that type into a new, pull out that variable into a new type, and then basically point all the stuff at it. So that it can become the owner of it, and all of the behavior around it is now localized in that one class. So you can either use extract delegate, or you can honestly, and I do this a lot as well, is just manually move the collection field, do a search and replace, and that solves it. Find the usages of getter, extract, and move. It's a little bit more complicated with the collection. I'm not going to walk through that. It's slightly more complicated, but not terribly so. And you just continue until there's no more usages of the getter. And you inline the getter and move it. There's a little bit more work where you may want to clean up encapsulation, method names, but that applies really to fixing either one. You want to, like here, this is a horrible name, right? Has not enough inventory for. So one of the first things I would do once I look at this and I say, this looks good, all my tests pass, after I do a commit, I would then say, okay, let me write enough tests that I could be satisfied that I'd get it right when I basically invert the message. Because I don't want it called has not enough inventory for. I want it has enough inventory for. But I'd want to do that carefully because I don't know about you. I get these kind of comparisons operators flipped all the time. I'm just really bad that way, which is why I love tests and TDD, because it means I don't have to worry about that anymore. And so, whenever a code doesn't have enough tests or classes are too big, I find this one, looking for this one code smell, primitive obsession, and its partner in crime, feature envy, and fixing those really improves so many different aspects, right? The readability and understandability. It puts concerns into things that are now just responsible for that one thing. So it basically fixes your single responsibility principle issues, but in a very specific way. And the process is mechanical, right? These steps, they're fairly mechanical. The hardest part is sort of figuring out when you move the method, when you first extract it, right, to get just the little piece that you want to move over, is what do you call it, right? The naming part. And you may not come up with a good name up front. Call it something, move it over, and it may become obvious what it needs to be once you move it over. But the process is fairly mechanical, but I do this all the time. And I do this as a natural course of just development, right? I don't immediately start out with creating new types, right? You look at some of my projects and you can see primitive obsession all over the place because I haven't gotten to it yet, right? So there is a cost to doing this, and you have to determine, is that cost worth it? Is this confusing? Are there validations, constraints, behavior associated with it that's mixed up with a whole bunch of other things and hard to find and hard to see, and especially hard to test? And again, for me, that's my primary goal. Because what I've found is if I focus on testability, how do I make this easier to test? All of this other stuff around understandability, good names, new types fall out from that, including things like ending up with a nice architecture like hexagonal architecture. Always have to put in a plug for hexagonal architecture. So when you're further constrained data exposure, so when you've created this new type, right, a lot of the things may be publicly visible or package private. And so you want to look for feature envy. You want to say, great, now that I have this method, am I exposing too much information that may cause or may already have further feature envy? So feature envy is something you want to look for in general, and that's where return values of methods you need to be careful of. Is somebody going to take that return value, right, that number, and do a comparison and make a decision that really belongs in the class that owns that information? And then there's other cleanup that I just generally do as a result of any kind of creating new class refactoring. Is there stuff that can be private? As you reorganize things, it's like, I want to make sure that I'm only exposing commands and queries, right, methods that should be used from the outside. And again, am I returning unconstrained type somewhere? That might be a problem. That might, again, be further feature envy that I would have to look at. So if you've got classes, and they don't have to be huge, but often, again, in the field, in the wild, as they say, I find lots of large classes. And often people are puzzled about, what do I do? And so just look through the instance variables. It's the first place I look. What does this do? What does this do? Where's the behavior associated with this? Who's modifying this? Why are they modifying it? What questions are people asking about this information? Are they comparing it to something else? All those questions are basically looking for primitive obsession. Then you have to decide, is how testable is this? Do we feel like we've got good test coverage for this specific aspect of this class? If it's just somebody's name, maybe stored as a string, although I gotta be honest, I'm like, well, maybe it should be a type. Because it's not always about testability. It's also about, am I passing multiple strings around and I want to tell the difference between one and another? But again, there's a cost to all these, because once you create types, they're not as simple to work with from a certain point of view, right? It's much easier to do stuff with an int than to do stuff with a class that doesn't let you do it. Now I've got to go add a method if I want to increase the inventory by an amount other than restocking to full. But honestly, I think that's good, because it requires us to think about, what do we want these things to do? Is that appropriate? Right? Maybe, you're working on a vending machine. It's like, oh, we need to do that because of X. Great. Okay. But we all could also test it. It's testable. It's easy to read, and it's easy to find the information about that. So I've been answering questions that popped up along the way. So this is your opportunity to ask any questions that you've been holding on to. So set them free if you've got them. And I'll answer them as they come in. And so this is my contact information. I'm fairly active on Twitter. You can hit me up with an email. I stream a lot on Twitch when I'm not training. And so things I do are building projects that I need and following this kind of process. So following test-driven development, just good object design with commands and queries, and hexagonal architecture is one of my favorites. So working with that, refactoring, doing a lot of refactoring, figuring out better ways to refactor. And so those are the kinds of things I do on my live coding stream. I have a YouTube channel where I've got videos taken from my stream where I, again, do this stuff. And also where I highlight certain tricks of using IntelliJ, refactorings, and some other techniques up on my YouTube channel.
All right. Well, I don't see any questions rolling in.
All right.
So on behalf of the Casey Jug community, Ted, thank you for presenting to us tonight. And on behalf of the organizers, thank you to the community for joining us, watching the videos later. We'll post some links to Ted's contact information as well as our presentation. Ted, do you have your presentation shared in your information?
I'll make it available. Yeah.
Awesome. All right. Well, thank you for joining us tonight, and we look forward to seeing everybody in February.
All right. Thanks, everyone.